So it turns out that this problem is actually remarkably similar to the skier problem we did in the previous problem set, and we're going to have to use a lot of geometry to help us get through this. So we're first going to try and solve for what your speed is when you just jumped off the swing, and to know that, we're going to have to know how much potential energy you started with. And to know how much potential energy you had, we're going to have to know what your height was above the ground. And doing a little trigonometry here, I find that the maximum height achieved by the swinger is 5 minus 4 times the cosine of 45 degrees. And this turns out to be 2.17 meters. And using the equation for gravitational potential energy, I find that my original potential energy is 1,302 joules. So I know that the original potential energy, this value of 1,302 joules, is going to be exactly equal to my final potential energy plus my final kinetic energy. So let's start by solving for the final potential energy. So once again, doing a little more trigonometry, I find that my final height above the ground is 1.54 meters. And using this height, I get a final potential energy of 924 joules. Now from this equation, I know that the final kinetic energy is just going to be equal to the difference in the two potential energies, which is equal to 378 joules. And using the equation for kinetic energy, I get that the final speed is equal to 3.55 meters per second. Alright, now that I know my speed when I'm jumping off the swing, it should be pretty easy to figure out how far I go. Alright, if I do a little geometry here, I see that the angle that the velocity vector makes with the horizontal is exactly 30 degrees, the angle of the pendulum. And now that I know that this angle is 30 degrees, I can solve for the x and y components of velocity, as shown here. Now I can use this kinematics equation here to solve for the time t when I finally reach the ground. And note that this value delta y is not equal to 1 meter when I jump off the swing. It's actually equal to this value hf. And plugging in my numbers here and then using the quadratic equation to solve for t, I find that t equals negative 0.405 seconds or t equals 0.761 seconds. And just like in the ski jumping problem, we know that it's actually this value for time we care about. This one we don't care about. So now we know it takes me 0.761 seconds after I jump off the swing to hit the ground. Now let's figure out how much I move along the ground in this time. So to calculate how far away from the swing I land, I'm going to use this kinematics equation here. And this time there is no acceleration in the x direction. And plugging in my numbers, I find that I landed 2.34 meters away from where I jumped off the swing. Great work.